This PPT is about calculation of modes of optical waveguide using Matlab. This PPT is submitted to Dr. Mike Goswami, Department of Physics. What is optical waveguide? An optical waveguide is a physical structure that guides electromagnetic waves in the optical spectrum. We have two views of optical waveguide in this slide. We have plastic jacket at the outside, then we have cladding and core. Total internal reflection take place in the optical waveguide if angle of incidence is bigger than the critical angle. In this example, if the incidence angle is bigger than the theta 1, we have the total internal reflection condition satisfied. How we can imagine the components of electrical and magnetic fields in the optical waveguide? This is the example how we can imagine those electric and magnetic fields in the optical wave. Using the Maxwell equation, we get the wave equation of Z components in the electric field and magnetic field. In these equations, Q square is equal to omega square multiplied by permittivity multiplied by permeability minus beta square is equal to refractive index square K naught multiplied by K naught square minus beta square. We achieve following the solution of Z component of electric field. In this solution, we see that both solutions become separated to each other. If they are totally independent of each other, we get two equations of solution of Z component of electric field. These are two equations. First one belongs to psi and second is a Bessel function equation. We have solution of psi is equal to exponential iota multiplied by m multiplied by phi. M takes integral values because phi is a cyclic function. The Bessel equation will be solved for both core and cladding. In the core, we have Bessel function in this form, where kappa is equal to n1 square k naught square minus beta square. It should always be greater than 0. In the cladding, we have Bessel equation in this form, where gamma is equal to beta square minus refractive index of cladding square multiplied by k naught square. On solving both Bessel equations, we got solution as this is for the core part, this is for the cladding. In the core we have A multiplied by Jm, which is function of kappa and r, plus A dash multiplied by Ym. In the cladding case, we have constant C multiplied by Km plus C dash constant multiplied by Im. In this case, A dash, C and C dash are constant. We make the Matlab code to find solution of all Bessel functions Jm, Ym, Km and Im. Code for Jm is following. We declared that the Bessel function of first kind Gm, trivial, closure, CLC and max. This is the number of points we want to plot. Then we have declared Z is equal to line space. We have taken the initial value, final value, and how many parts we will have to plot by mx. Then we have applied the hold on. We have taken the first three values of m. Then we have defined the function j is equal to Bessel j mz. This is the inbuilt function for the jm. Then we have defined the h function as plot in which x-axis is z and y-axis is j. Then we have defined the figure. We have labeled the x-axis as z and y-axis as j and z, and we have defined the font size. We define the text m is equal to 0 at x-axis 1.1 and y-axis 0.85 and set the font size. We have defined the text as m is equal to 1. It has x-axis at that x-axis 1.8 and y-axis 0.65. We have defined m is equal to 2 at x-axis 3 and y-axis 0.55. Then we have set the line width of h as 1.5, and we have set the new size of tick marks on both axes. This is the plot of GMZ. We have the x-axis, different values of z. What we observe that all these three values of m oscillate around the center. So it is not dying function, it is not exponentially increasing function, it is an oscillatory function. In this slide, we have code of ym values. We have declared the plot of Bessel functions for the second kind ymz. Then we have closure, clear CLC. We define the nmax is equal to 101. We define the z is equal to line space 0.01 and maximum 10. Then we have applied the hold on. We have defined the first three values of m, and we have defined the val as Bessel Ly. It is an inbit function for Bessel y. Then we have defined the h plot yz. Then we have defined the figure. We have defined x label and y label, x label as z-axis and y label as ymz. Then we have defined the text. This is the x-axis, this is the y-axis. At this value, we have the values of m appear. We have defined the x point and y point for m is equal to 1. Then we have defined the x point and y point for the m is equal to 2. We define their font sizes. We set the limit of axis. This is the limit of x-axis 0 to 10, and this is the limit of y-axis minus 5 to 1.5. Then we have set the line width of h. Then we have set the new size of tick marks on both the axes. Then we have close on. This is the ym function. This is oscillatory for most of values, but we have a special case. When it comes close to 0, it becomes monotony. It goes to infinite. This slide shows for k values. We define the plot of modified Bessel function for the second kind Tm. Then we have the clear all, close all, CLC. We define the nmax value. We define the z as line space 0.013 and the nmax value how much points we want to generate. Then we have the hold on. Then we have first three values of m defined, and we have k is equal to Bessel k. This is the inbuilt function for the Bessel function of second kind kmz. Then we have defined the h as plot of z and k. Here on z axis is z and on the y axis we have k. We define the figure properties as x label z axis and its font size 22. We define the y label as kmz and its font size 22. We define the text at 0.2 and 0.8 for m0 to 0 and font size 18. We define the text at the point x-axis 1 and y-axis 0.8 for m is equal to 1. We have defined the text as x point 1.5 and y 0.8 for m is equal to 2. Then we have defined the limits of x-axis from starting to 3 point and y-axis from starting to 5. Then we have set the line width to 1.5 for the edge. Then we have defined the new size of tick marks on both the axes. Then we have closed all. This is the plot of km and z. So we see that kms continuously decrease as the value of z increases and it die out. And it also relates to the physical condition of cladding. In this slide, we have code for IM values. We have defined the plot of modified Bessel functions for the first kind IMZ, the close all, clear all, CLC. We define the nmax, number of points for the plot. Then we have defined the z is equal to line space, starting point is 3. Then we have nmax values, how many points we want to generate on the z-axis. Then we have hold on, we define the first three values of m. Then we have defined the function y as Bessel I. In this function, we have input as mz and output as y. Then we have defined the h as plot, which have on x-axis we have taken the z and on y-axis we have taken the y, capital Y, that is Bessel function Li. Then we have defined the figure properties. We have X label as Z and its font size 22. We have Y label as IMZ and its font size 22. Then we have defined the text for the X axis 1.1 and Y axis 1.7. For M is equal to 0 and font size 18. We have set text for X point 1.75 and Y point 1.7 for the value of M is equal to 1. We have set the text 2.4 as X point and 1.7 for Y point for M is equal to 2. And we define the font size as 18. Then we have set the line width of H as 1.5. Then we have set new size of the tick marks on the both axes. Then we have closed. This is the plot of IMZ and Z. What we observe that as the value of Z increases, value of IM continuously increases. It is not physically possible. We plotted values of Jm, Ym, Km, Im, but we have to also think qualitatively how solutions should behave and eliminate values which are not physically possible. The solution of O is oscillatory and finite at center. The solution in the cladding will decrease monotonically and the distance from the center increase. Ym have singularity, so in solution we should eliminate A dash in solution equation. In the cladding case, the function Im continuously increase as we move away from the center, so we should also eliminate C dash. So the solution of Z components of cladding will is given by this, since C dash and A dash are eliminated. Similarly, we let the solution of Z components of magnetic field